there will be two presentations. One is about sewage collection and treatment in Maryland and the United States. It's all handled pretty much under the Federal Clean Water Act, and then each state has its own special rules, which I'll talk about. So we'll go through sewage first, and then stormwater and flooding. So, and I don't know whether, should we make this more interactive if there are questions?
No, the end.
No?
Yeah.
Okay.
Questions at the end.
Yeah,
Okay, questions at the end. All right, very good.
So are we?
We are rolling. You are free to go, sir.
Okay, so Maryland, where we are today, is home to over 5 million people now. Most of them, about 80%, live in the cities, but many live in the suburbs and rural areas of the state, which you have visited. And I'm going to talk a little bit first about sewage treatment in the cities because I think this is most applicable to the situation that we're seeing in Rio today. So in the United States, there are basically two types of sewage collection systems. Of course, the first step is to get the sewage from the home to the sewage treatment plant. This stands for publicly owned treatment works, but it could be privately owned as well. We have both public and private. And the older type of sewage system is called a combined system. And this is where the sewage and the stormwater from the street runoff go into the same set of pipes and go to the sewage treatment plant. And what happens is when there is a big flood, a lot of rainfall, there's an overflow designed into the system which spills the mixture of sewage and stormwater directly into the Chesapeake Bay or whatever the body of water is. So the system in Rio right now, because the collection system needs so much work, much of your sewage winds up in stormwater. So this is probably more similar to the situation in Rio than the other typical kind of system in the U.S. is called a separate sewer system. And this is where the sewage and the black pipes from the industries and the homes goes directly to the treatment plant. There is not a designed overflow because the stormwater is collected in a separate system of pipes which go into the water body. And so this is largely what Baltimore City is like. And on the other hand, Washington, D.C. is one of our largest cities with a combined sewer system. And Washington right now is in the middle of a $4 billion restoration effort to try to correct the spilling of sewage from the combined system. So I'm going to focus on Baltimore for a minute. This is the Baltimore newspaper from September 1911. And it's announcing this engineering marvel, the new sewer system for Baltimore. So it's been over 100 years since our system was built, and right now we're in the midst of a rehabilitation program to fix the collection system that's going to cost estimated $4.5 billion. So even though Baltimore has a much more developed sewage system than Rio, we are also at the same time in a major rehabilitation effort. So hopefully there are things from our experience that can be of help there. This is the web page from one of our non-governmental groups, I guess social action group in Brazil. this this is Blue Water, Baltimore, and they have a whole web page devoted to educating citizens about the problems with Baltimore's system, and it's basically, as it says, the dilapidated state, the disrepair of our sewage collection system is the reason for the spills and problems. So, major effort in the United States underway. All the cities, the old cities in the country, Baltimore, Washington, Philadelphia, New York, they're all undergoing right now rehabilitation of infrastructure required by the Federal Clean Water Act. The way the Federal Clean Water Act works, the U.S. EPA is in charge, but they can delegate responsibility to the states, and so the states and EPA working together are taking the enforcement action. And this rehabilitation is a 20-year project, which right now is scheduled to be completed by 2021. So we're literally in the middle. In addition to rehabilitating the system, a large part of the sewage spill problems that we have occur because of improper maintenance of the system. And in the Clean Water Act, this is referred to Capacity Management, Operation, and Maintenance, or CMOM. And it has to do with making sure that the collection system, the size of the pipes and the pumps are large enough to handle the sewage that is expected to come into the system. That's capacity management. And then operation and maintenance has to do with ensuring that the system's kept clean, that there are preventative measures in place. For example, there's something called prevention of fats, oils, and grease, or FOG. Restaurants and homes and some industries, if they discharge things into the sewer system, it can literally gum up the works. The fats, oils, and grease form clots, just like in your circulatory system if you have high cholesterol. And then education of property owners and maintaining the system in good repair. So moving on to the actual sewage treatment plants themselves, we have many different technologies and different size plants in the state of Maryland, and I'm going to talk a little bit about the technologies. The basic treatment processes we use, pretreatment to get grit and logs or whatever else may come into the system out before it goes into the primary treatment area where chemicals are added and you get coagulation, the sediment and particles coagulate and settle out. Then it moves into secondary treatment where we use biological organisms to treat the sewage, and then advanced areas, the bioreactor and thickeners in the system will allow all the sludge to settle out and discharge fairly clear, clean water. And the final step before discharge is chlorination to kill the bacteria, and that then is discharge. This is very similar to the Alegria plant. The design of the Alegria plant in Rio is very similar to this. The difference is Alegria, and my understanding is most of the other plants in Rio do not have disinfection as an end step. And this is something that we looked at early on in my travel to Rio, and something we believe that needs to be seriously considered as an addition to your sewage treatment processes. And I know there's some controversy. We heard it expressed that chlorine can be toxic to wildlife. However, as high as loading is in Guanabara Bay right now, we don't believe that chlorine is going to cause a problem for the fish. It will in fact be dissipated almost as soon as it gets discharged into the bay, because the bay is so heavily loaded with organic material and bacteria. But what it will do is reduce the human pathogenic viruses and bacteria that are a big problem in Guanabara Bay. So most of the treatment facilities are like what I just described there, pulling out suspended solids and biochemical oxygen demand, again, very similar to Alegria. And the treatment steps we refer to primary, pulling out basically the big pieces, screening and floatable material, trash or whatever. Secondary treatment, the biological treatment process, and then a typical plant with primary and secondary treatment is shown in this graphic here. I mentioned the screening grit, primary sedimentation, the sediment from here, also from the bioreactor, moves into sludge processing, and I'll talk a little bit more about that in a minute. My understanding is most of the biosolids or sludge in Rio wind up going to landfills. In this country, other disposal methods in addition to landfills are used. Then in Chesapeake Bay, in order to remove the nutrients, which are the big pollution problem in the bay, we've added what we call biological nutrient removal, starting back in '84, upgrading all of our state's major treatment plants with biological nutrient removal first, and then more recently, beginning in 2004, we started what we call enhanced nutrient removal, even bringing nutrient levels down further. And the company that I've been working with, KCI Technologies, is doing a lot of the design and engineering work for these advanced treatment plants. And this is one of the ones we're working on. This is the largest plant in Maryland. This is the Back River Wastewater Treatment Plant, and the largest plant on Chesapeake Bay is Blue Plains in Washington, D.C., that collects sewage from the whole Baltimore, Washington metropolitan area, but it's a very large facility. And Back River is known in the neighborhood. You can see these kind of gold domes there. When you drive by on the road, these are towering structures. They look like two golden eggs. And they're actually digesters where the sludge goes in, is digested. They produce methane gas, which is burned for energy, which powers all the pumps in the plant. And then the digested sludge is then highly treated to produce what we call Class A sludge, which has been composted to destroy pathogenic organisms, and then it can be used as a soil amendment for cropland and gardening. There's actually a product that's sold in many of our gardening stores called Synagro, which is a sludge product, which home gardeners, unless they read the label carefully, don't really realize, but it's used pretty widely. And this gives you an idea of the number of discharges we have across the state of Maryland. The red are all of the towns, municipal and county discharges, and the green are industrial, and they're all held to very high discharge standards. And these are the major plants. These are the ones that are larger than 500,000 gallons per day, which is roughly equivalent to, I think, probably 20,000 people. So all the bigger towns have advanced treatment that I mentioned, biological nutrient removal and enhanced nutrient removal. And we're right here in Annapolis, and the sewage is going out right through that dot right there. And then in more rural areas of the state, the treated sewage is not discharged into the water or the river. It's actually used to irrigate crops. And it's typically not used for food crops, but it can be used for corn that's grown for animal feed. I should say not human food. But a lot of places have gone to growing hay because that's and straw because that's very important. We'll talk in a minute about sediment erosion control. There's a big market for those kind of crops. And in the U.S., we also have what we refer to as non-traditional treatment systems, constructed treatment wetlands. This is a fact sheet from the U.S. Environmental Protection Agency, and wetlands are very effective at removing contamination from sewage and runoff and other things. And it's fairly simple construction. The wastewater comes in, it's set up so it filters through the wetlands before it passes out, and it can then be discharged. And this is just a photo from the fact sheet of a large wetland treatment system for a hog operation. These things can be used for animals as well as humans. And of course in Rio, there are a lot of mangroves growing, and mangroves are also used, like wetlands, to treat sewage. This is from an article about a constructed wetland treatment system in China. And in fact, when I was in Rio and we went out to what's the town at the north part of the bay, Majay, thank you. They were in the midst of designing and building a treatment system like this that would allow the mangroves in the coastal area to treat the sewage from a school there. And so there are what we would call non-traditional opportunities that could be very beneficial in the Rio vicinity. And then in rural areas, we basically dispose of sewage in the ground. And a house, rather than having a connection to a sewage treatment plant, will have a septic tank and a drain field. And basically the sewage comes out of the house, the solids settle in the tank, the liquids go off the top into what's called an infiltration trench, where it can then percolate through the soil. And if it's designed properly, the soil removes all the bacteria before it gets into the groundwater. One of the big problems we're having is a situation where the water table, the groundwater is too high, the bacteria doesn't get removed, and these can create quite a serious public health problem if they're not properly maintained. We have regulation requirements. These are done by the state and local health departments to protect public health, prevent exposure to sewage, and the homeowners and businesses pay for their systems themselves. These are called private sewage treatment systems, and you can see roughly $5,000 to $7,000 per home is part of the capital cost of the home to put the system in, and about $100 a year for pumping and disposal of septic, the solid waste. So it's a pretty inexpensive way to treat sewage. And the septic, I mentioned the septic tanks, they need to be pumped out, and the solids are pumped out and taken to sewage treatment plants for disposal. So the funding for all of this initially came from the federal government through what was called the Construction Grants Program that was passed with the Clean Water Act in 1972. And they paid up to 85%. In the 90s, the Construction Grants Program was changed to what's called the State Revolving Loan Fund, and the federal money then was given to the state to put in a state-operated bank, and the state then could lend the money to sewage treatment plant owners at very low cost, very low interest. The owners would pay back in, and so it's called revolving, to keep the fund available for upgrading additional plants. And this has been a very popular and successful program. So the capital funds come federal and state, more fed, less state, into this bank that I mentioned, where they loan the money out to communities and businesses and individuals, and it pays back. And so this is called revolving. And right now, Maryland's revolving loan fund has a capacity to hand out about $700 million a year in low interest loans. So it's a very effective way to finance sewage treatment. It's also similarly used for water. And the individual homeowners and businesses pay monthly, quarterly, or annual fees to whoever it is that owns their sewage plant, somewhere in the range of $155 to $615 per year. It's actually going up because of all these rehabilitation programs that I've talked about. But that pays for basic debt service and O&M, operation and maintenance of the system. And then businesses that are discharging a higher strength waste may pay a surcharge. So that the people who use the system finance the basic operation of the system. The advanced wastewater treatment, the state shares the cost on that with a special grant program, and it's general obligation bonds, meaning the state government borrows the money to upgrade and then pays it back over a 30-year period. The enhanced nutrient removal, we actually created a special fund called the Bay Restoration Fund, and everybody in the state who has a wastewater treatment system pays $5 a month toward this fund. So an individual homeowner, I pay $500 a month. If I live in an apartment complex, that apartment complex has 500 homes in it, I pay 1/500th of their fee, which is roughly $500 a month. And $5 a month. And a business that has a lot of sewage that's equivalent to, say, 10 homes, instead of paying $5 a month, would pay $50 a month. So it's rated or adjusted based on what your use of the system is. All of this is regulated under the Federal Clean Water Act and the program called NPDES, which is National Pollutant Discharge Elimination System. And EPA develops criteria, different dischargers, and requires certain pollution control technologies be in place to make sure that sewage is treated properly. If the basic technology is not good enough, as it is here in Chesapeake Bay, we need more protection. A water quality-based approach actually is put in place. It requires even more advanced treatment. So the biological nutrient removal, enhanced nutrient removal I talked about before aren't done everywhere, but they're done in places like Chesapeake Bay where we need extra nutrient reduction, and that is in order to achieve water quality standards for the bay. And there are many other water bodies, San Francisco Bay, the Great Lakes, that have these additional special requirements. And based on my study of Guanabara Bay, there is very high nutrient loading to the bay, and actually the JICA studies came to the conclusion that even with secondary treatment, which removed the BOD load, there's enough nutrient in the discharge to grow the BOD back again in algae in the bay, so that eventually I think Guanabara Bay, to really meet standards, is going to need even more advanced treatment. But one step at a time. Let's get the basic collection and primary and secondary treatment in place. Every plant has a permit with specific limits. Management practices required, like I mentioned, CMOM, monitoring, reporting, and this is important. And I don't know whether anything like that is in place for Rio, but many industries discharge into the sewer system. And in order to avoid poisoning the biological treatment system in the sewage plant, there needs to be pre-treatment requirements in place to ensure that if industries are discharging something that would harm the biological system, that can be removed prior to discharge into the sewage treatment plant. And this is something that Baltimore City struggled with for a long time, where industries were poisoning one of the sewage plants pretty regularly, and they made a major effort to go in and establish pre-treatment requirements, and they've actually fixed that problem. And that's also important because if you want to use the sludge for cropland, or I've mentioned the Class A sludge at Back River that is even used on home gardens, you need to have metals and other things removed from the sludge. So those things all go together. And then, of course, there are limits on what can be discharged, and you have to monitor that and report it to the state government. And this is something that we didn't study in Rio, but it was being studied by another company under contract, PASAM, and I understand that there are a number of issues that need to be addressed in terms of improving the monitoring and reporting of industries and sewage plants in Guanabara Bay. And this is essential to making sure things operate properly. And systems that have a combined sewer, like Washington, D.C., have additional requirements on them. And the way that they try to deal with the contaminated runoff is to use the collection system for storage. And in Washington, D.C., they're actually building large underground tunnels which will hold the sewage and stormwater mix and discharge it at a rate that the sewage plant can treat. And this is coupled with stormwater management, I'll talk about in a minute, to try to reduce the amount of volume of stormwater going into the system. But I think that there is a potential, and one of groups working on the sewage problem in Rio de Janeiro was looking at the fact that much of the sewage goes into these ditches and waterways that lead to the bay. And by collecting and treating the mixture of stormwater and sewage from those waterways to use the extra capacity that you have on plants like Alegria, may be a quick way to begin to bring the sewage load to the bay down. And it's kind of analogous to the way that we're dealing with combined sewer overflows. The sewage is going into the waterways, and it is, particularly during dry weather, just moving very slowly. If you could capture it there and pump it to a sewage plant, I think it would make a big difference. Sewage sludge, of course, it can go to a landfill. We, under the Clean Water Act, manage this carefully to make sure that any toxics or pathogens are addressed in the sludge through pretreatment. Generators, processors, and disposers and users have permits that require special handling. Goes to the municipal landfill. Some of it is incinerated. Cropland application is soil conditioner. About 40% of our sludge goes out on cropland, and I mentioned composting and sale for gardening. And I should probably also mention that an additional measure here probably should have added to this. The Back River plant is actually using the sludge in a digester to produce methane gas to generate energy. So I think that's kind of the wave of the future for sludge and biosolids, is to use it to generate energy as much as possible as well. And of course, none of this equipment works properly without a well-trained workforce. And so we also have operator training and certification requirements. Everybody has to have an operator's license, depending on the size of the plant. The level of license requires coursework and examinations to maintain your license, just like for an engineer or a doctor or a nurse has to maintain their license. The operators have to do that. And the Department of the Environment maintains this, and there's an elected board of wastewater operators from their association that oversees this to make sure that it's all fair. And then enforcement, primarily state responsibility, but EPA watches over that. We need to make sure that all of these requirements that I've been talking about are maintained, adhered to, and penalties can be imposed, financial penalties, but also what we call injunctive relief. If you've got a broken pipe or whatever, you got to pay to get it fixed right away, in addition to paying a penalty. And we have had some criminal violations where people have actually gone to jail for falsifying reports. And backing it all up, if the state government or the federal government is not taking sufficient enforcement action, the Clean Water Act has citizen lawsuit provisions where any citizen who sees a violation can file a notice of intent to sue. The government has 60 days to fix the problem. If they don't, then they can go into the courts themselves. And we've had many citizen suits that have been very successful at forcing businesses and municipalities to clean up pollution. And I think in Brazil, the counterpart to the citizen lawsuit is your public prosecutor. And I know that there has been some action by the public prosecutor recently. And then you have this whole system in place. You got to make sure that you don't allow growth and development to overwhelm it. as can happen in many places. And as you know, in Rio, a lot of the illegal developments are causing problems. And in Maryland and most other states in the U.S., there are land use requirements, and we have in place rules to require that comprehensive land use management to make sure that they have adequate water supply and are dealing with the pollution properly. And the law actually requires sensitive areas and water resources elements to make sure that the plans take these factors into consideration, and it requires that our Department of the Environment and Natural Resource review those and approve them prior to local governments adopting these plans. And this diagram just kind of shows how it works. Local government comes up with a comprehensive plan with oversight from the state to make sure they've considered all of the elements that are needed to protect water resources and everything else. That goes then to the water and sewer plan, specific where is sewer going to be provided and how many homes or businesses can go onto that sewer system. And once the plan is done, there are a number of permits and approvals that have to be obtained from water appropriation, which has to do with how much water they take in for public use, facility construction, protection of wetlands. I mentioned the discharge permit, and every building needs a development plat and a building permit. So the development would be the community, 500 homes or whatever it is, and each individual home would need a building permit in order to be built. And then the local government has to monitor the capacity of the wastewater and the water system, make sure that that capacity is not exceeded, and if it looks like they're getting to capacity, it goes back and they have to redo the comprehensive plan. And we call that the water resources planning cycle. And without that planning, all of the other things I've just talked about could be overwhelmed. So you really need all of these components in place to have clean and healthy water. So I know it's a lot, but there are a lot of parts that we need to protect. So that's, believe it or not, a quick overview of sewage treatment in the U.S. And all these things are in place and operating as we speak. Not flawlessly. We have sewer spills and other problems, but it's working pretty well.